Problem 1. The stochastic process xt is a real wide-sense stationary with autocorrelation Rxx torque and power spectral density Sxx omega. Show that Question A. Rxx torque is real and even. Question B. Sxx omega is even and non-negative. First, we know xt is a real wide-sense stationary. Then, Rxx torque is also real. So, we have an equation that Rxx torque equals Rxx t plus torque t equals Ext plus torque xt equals Ext xt plus torque equals Rxx t plus torque, and it's equal to Rxx negative torque. So when Rxx torque equals Rxx negative torque, we can know that Rxx torque is an even function. For question B, to prove the even function, we have the similar steps. Sxx omega equals integral function from negative infinity to infinity Rxx torque e to the negative j omega torque derivative torque, and it equals to integral function from negative infinity to infinity Rxx torque cosine omega torque derivative t minus j integral function from negative infinity to infinity Rxx torque sine omega torque derivative torque. And for the second part, Rxx torque is an even function, and it times sine omega torque, which is an odd function, so the combination is an odd function. Then it equals to 2 times integral function from 0 to infinity Rxx torque cosine omega torque derivative torque equals 2 times integral function 0 to infinity Rxx torque cosine negative omega times torque derivative torque, and this one equals to Sxx negative omega. So recall from the first question, when Sx omega equals Sx negative omega, it will be an even function. Then, to show this function is non-negative, let's look at an example as the following graph. For this graph, we suppose that H omega is an ideal bandpass system, where H omega equals 1 when omega is bigger than omega 1 but smaller than omega 2, and H omega equals to 0 otherwise. Then let's look at the Eyt square. To calculate Eyt square, it equals 1 over 2 pi integral function from negative infinity to infinity, the absolute value H omega square times Sxx omega derivative omega equals 1 over 2 pi integral function from omega 1 to omega 2 Sxx omega derivative omega, and we can know that this function should be always non-negative. So in order to keep this inequality always true, we should set that Sxx omega is always larger or equal to 0. So we can see that Sxx omega is non-negative.